Hi, everybody, and thank you so much for joining me. This is lesson 2-4 operations with scientific notation. And the essential question is how do you add, subtract, multiply, or divide using scientific notation? Ooh, not only do you have to write the numbers in scientific notation, but now you got to add, subtract, multiply, and divide. I'm just going to tell you something. Use the calculator when they let you, okay? But let's watch. Oops, sorry.
Ever thought about the
But the essential. Okay, but now let's watch the video. Okay.
Ever thought about the weight of the Earth? We are talking serious, heavy weight. To be a little more specific, we are talking about the mass of the Earth being 5 and 97 hundredths times 10 to the 24th power kilograms. Sounds pretty heavy, huh? But not when you compare it to the mass of the Sun. Wow! The Sun weighs 3 and 99 hundredths times 10 to the 30th power kilograms, approximately. So, how many times heavier than the Earth is the Sun? And does this look like a fair match? Follow along with this lesson and you'll know how to find out.
Okay. And so what we're going to do once again is we're going to add, subtract, multiply, and divide numbers in scientific notation.
You can add or subtract numbers written in scientific notation. Here are some examples. You can add or subtract numbers in scientific notation directly if they have the same power of 10. Numbers may already be written with the same power of 10. But if not, you can rewrite the numbers.
Okay, so let me just go over like the first one. If I have like, for example, 1.1x or 1.1y plus 2.3y, then you just add the 1 plus 1.3 plus 2.3 because the exponents are exactly the same. That's all you do, and you just keep the y. You keep the exponent, 10 to the third power. Now here, the powers, 10 to the fourth power and 10 to the third power, are not the same. So you have to make them, rewrite them so that they're the same. You can either write them both with 10 to the third power, or you could write both of them with 10 to the fourth power. It's up to you, however you want to change it.
So they have the same power of 10. Now you can add or subtract the numbers by adding or subtracting the multipliers and keeping the same power of 10. Or you can rewrite the numbers in standard notation to add or subtract them.
Oh, I like that one. You can always go back to writing them in standard notation and then getting the answer, okay? So that's another way.
When numbers are in standard form, you already know how to add or subtract them. Both methods will give you the same answer, but each method has advantages and disadvantages depending on the numbers you are working with. For example, extra calculations with very large or very small numbers in standard form can introduce errors in your work.
I like that strategy. So remember, there are two different strategies. One is you can make sure that the power of 10 is the same and then just add or subtract the coefficient and keep the same power. Or the other one is you can rewrite the number in standard form, add them or subtract them, and then get the same answer. But as it was mentioned, like if you have so many zeros, it's easy to miscount 1 0. So those are the disadvantages for going from scientific notation to standard notation.
Let's look at an example of adding or subtracting numbers in scientific notation. This table shows the population of the 3 largest countries in North America in 2011. Find the total population of these countries. Here's one method. You can add the numbers directly if they are written with the same power of 10. 2 of the 3 numbers have the same power of 10, 10 to the 8th power. One of the 3 numbers has a different power of 10, 10 to the 7th power.
So then what we need to do is we need to change that 10 to the 7th power. We're going to change it to 10 to the 8th power. So this is how I remember. Since this power, you're going to make it bigger, then the coefficient, you need to make it smaller. And how do we make the coefficient smaller? By moving the decimal. So we need to move the decimal to the left, okay?
Write the population of Canada so it has the same power of 10 as the other countries.
So right here, it's going to be 10 to the 7th power. So then 10 to the 7th power. It became 10 to the 8th power. So that means that the coefficient, instead of getting bigger, it should get smaller. So it's not going to be 33.8. It's going to be 0.338. So that it keeps that balance.
That's right. 3 and 38 hundredths times 10 to the 7th is equal to 338 thousandths times 10 to the 8th. Now add the multipliers.
So they call it the multipliers. I call it the coefficients. Okay, they all mean the same. So 3.1 plus 1.1, that's going to be 4.2, plus 0.338 is going to be 4.538, I think.
That's right. The sum of the multipliers is 4 and 538 thousandths. Now include the power of 10, so the answer is written in scientific notation.
And notice they all have 10 to the 8th power, 10 to the 8th power, 10 to the 8th power. So this is 10 to the 8th power.
That's correct. The sum in scientific notation is 4 and 538 thousandths times 10 to the 8th power. The total population of the United States, Canada, and Mexico is 4 and 538 thousandths times 10 to the 8th.
Any questions? Let me know, okay?
Now let's look at adding or subtracting numbers in scientific notation another way. You want to find the total population of these 3 countries. First, write each of the numbers in standard form.
So this 3.1 times 10 to the 8th in standard form is going to be 31. And then I need 8 numbers after the decimal. So that's 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be that one. And then 338. And I need 7 numbers after the decimal. So I already have 2 right there. 2, 3, 4, 5, 6, 7. Then the next one is 111, and then I need 8 numbers after the decimal. So I already have 1. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I think I should have it right.
Correct. 3 and 1/10 times 10 to the 8th power is equal to 310 million. 3 and 38 hundredths times 10 to the 7th power is equal to 33,800,000. And 1 and 1/10 times 10 to the 8th power is equal to 110 million. The sum of 310 million, 33,800,000, and 110 million is equal to 453,800,000. Finally, write the answer in scientific notation.
So when I'm looking for scientific notation, remember that the coefficient has to be either 1 or less than 10. So between 1 and 10. So the only number that right here that is between those two numbers is 4.538. Now I got to count, well, how many numbers are after that 4, after that decimal? So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 10 to the 8th power. Okay?
That's right. The sum in scientific notation is 4 and 538 thousandths times 10 to the 8th power. Using this method, the total population of these 3 countries is 4 and 538 thousandths times 10 to the 8th.
Any questions, please email me.
Numbers in scientific notation can be multiplied and divided directly by using properties of exponents. You can use these skills in a question like this. When the Sun makes an orbit around the center of the Milky Way, it travels 2 and 25 thousandths times 10 to the 14th power kilometers. The orbit takes 225 million years. At what rate does the Sun travel? Write your answer in scientific notation. Understand what the question is asking by analyzing the information you are given. You're trying to find the number of kilometers that the Sun travels around the Milky Way per year if it travels 2 and 25 thousandths times 10 to the 14th power kilometers. The orbit takes 225 million years. This is the rate that the Sun travels. You can think of its rate as its speed. Use the information you have to formulate a plan. Use the terms distance, rate, and time to write an equation that relates the information you have and the information you want.
So a little while ago when he had that little sign, it said rate and it said miles per hour. So right here, what is the rate? That's what we're looking for. So I choose rate, it's miles, so or kilometers, in this case, kilometers. So it's going to be distance divided by the time. So remember, usually when you're talking about rate is the distance divided by time, okay?
That's right. Rate is equal to distance divided by time. Now that you have a formula that shows the relationship between rate, distance, and time, you can substitute the values you have.
So now you're going to divide, okay? You're going to divide those two numbers, the kilometers divided by the years.
You've seen that it may be easier to work with scientific notation. Which number is already in scientific notation?
So remember, scientific notation is a number less than 10 times 10 a power of 10. That one.
That's right. The number in scientific notation includes a power of 10. Now write the other number in scientific notation.
So the other number was 225 million years. So after the 225, it's going to have 6 more zeros because it's million. But the coefficient will be 2.25, and then it was already 6 zeros, but there's 2 more after the decimal. There's a 2 and the 5, so it's going to be 6, 7, 8, power of 8, okay?
Excellent. 225 million is equal to 2 and 25 hundredths times 10 to the 8th power. To divide two numbers in scientific notation, divide the multipliers first.
Okay, so I'm going to divide. And remember, on your calculator, you put first 2.025, and then you press divided by 2.25. So when I divide that, I get 0.9, okay?
Great! 2 and 25 thousandths divided by 2 and 25 hundredths is equal to 9 tenths. Next, we'll divide the powers of 10.
Ooh, let me show you how I can divide that using my calculator. 10 to the 4th power divided by 10 to the 8th power. So let's go to the SBAC calculator. What was it? 10? 10 to the something power, 14 power, and then divided by, was it 10 to the 8th? Did I get it right? I don't know. 10 to the 8th power. So that is 1 million, if that is correct, 1 million. So 1 times 10 to the 6th power. But let me see if I did it right. 14 and 8th. Yep, it said 1 millionth, and it had 6 zeros, so it's going to be 10 to the 6 zero. Let me show you something. How could I have gotten the 6 from the 14 and the 8? You just subtract. 14 minus 8 is 6.
Right. 10 to the 14th power divided by 10 to the 8th power is equal to 10 to the 6th power. Now combine what you found to write the answer in scientific notation.
Now, this is a big aha moment. When I first started teaching these concepts, I didn't realize, oh, this one is not in scientific notation. 0.9 is not in scientific notation. So remember that coefficient has to be less than 10, but it cannot be less than 1. It has to be greater than 1. So that becomes a 9. Now, from 0.9, you made it bigger. So that means because you made the coefficient bigger, I got to make the exponent smaller. So instead of 6, I'm going to put a 5, okay?
That's right. The quotient is 9 times 10 to the 5th power. Because the question is asking for the rate, you have to make sure the answer includes the correct units. What are the correct units for this rate?
So this is kilometers per year, because it says kilometers per year on the problem, okay?
Correct. The units are kilometers per year. Use estimation to check the reasonableness of your answer. You solve the problem by writing 225 million in scientific notation. You could have written 2 and 25 thousandths times 10 to the 14th power in standard notation instead, to perform the division. Would this be a good way to solve the problem? Explain your answer.
I think it'll be good. It's just I just have to go slow. It is okay. Now, the other thing that I could have done is canceled out all the zeros, and then I would have just, it would have made it a little bit easier. It's okay. It's acceptable. Hmm. It is acceptable. Ah, they wanted me to write more words. It is acceptable. Okay. And now I check.
The table shows the approximate areas for 3 continents given in square meters. What is the total area of these 3 continents? Write the answer in scientific notation using more appropriate units. Use a scientific calculator to solve this problem. On many scientific calculators, you can enter numbers in scientific notation by using the EE key to take the place of times 10. To find the total area, you need to find the sum of the 3 areas. Which way would you write these 3 values to find their sum?
So they said that they use EE for the exponents. So the EE exponents. So what did they? So then I would add this one, right? 4.4 times 10 to the third power, and then plus 3.00 times 10 to the 13th power plus 1.04. I'm going to say this one to find the sum.
That's right. The sum is 4 and 4/10 times 10 to the 13th power plus 3 and 2/100 times 10 to the 13th power plus 1 and 4/100 times 10 to the 13th power. Now enter these values on the calculator to find the sum. How would you enter these values into a scientific calculator to find their sum?
So this specifically, they said to use EE. So EE 4.4, EE 13th, and then 3.02, EE 13th. Sorry, EE 13. I'm going to say with that one.
That's right. On screen, the calculator shows 84,600,000,000. How would you write the sum in scientific notation?
So once again, the coefficient has to be less than 10, but greater than 1 or greater than 1. That looks like this one. Now, how many numbers do I have after the 8? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think it has 13 exponents, 13 numbers, so it's going to be 10 to the third power, okay?
That's right. The answer is 8 and 46/100 times 10 to the 13th power square meters. Large areas are usually written in more appropriate units, such as square kilometers. If 1 kilometer equals 1,000 meters, how many square meters are in 1 square kilometer?
I was getting confused on this one, but as he said, if 1 kilometer equals 100 meter, what is it, 1,000 meters? How many square kilometers? So that means it's going to be 1,000 square meters, okay?
That's right. 1 square kilometer is equal to 1,000 squared square meters. How is 1,000 squared written in scientific notation?
So remember, 1,000 means 10 to the third power. So what 10 to the third power to the second power? So I'm going to have a total of 6 zeros. So it's going to be 10 to the sixth power.
Great job. 1,000 squared is equal to 10 to the 6th power. So, to write 8 and 46/100 times 10 to the 13th power square meters in units of square kilometers, divide it by 10 to the 6th power square meters.
So on this one, I'm not going to do anything with the 8.46. So I'm just going to put it as 8.46. But what happens there? 10 to the 13th power divided by 10 to the 6th power. Think of it. If I have 10 to the 13th power, I'm going to have 13 zeros. And then 10 to the 6th power, I'm going to have 6 zeros. And those zeros are going to cancel out. So 13 minus 6 is 7. So I'm going to have 7 zeros left over because, so it's going to be 10 to the 7th power.
That's right. The quotient is 8 and 46 hundredths times 10 to the 7th square kilometers. Now the answer is in more appropriate units of square kilometers. The total area of the continents is 8 and 46 hundredths times 10 to the 7th power square kilometers.
And if you have any questions, just text me.
Now let's practice with.
So number 1, it says, how do you add, subtract, multiply, and divide whole numbers written in scientific notation? To add or subtract, rewrite the numbers to the same power of 10. Add or subtract the multiplier. They use the word multiplier instead of coefficient, but that's okay, multipliers, and rewrite the numbers in scientific notation. To multiply or divide the multipliers, use the rule of exponents to multiply. And I haven't taught you the rules of exponents. I will be teaching them to you next week, okay? To multiply or divide powers of 10 and rewrite the scientific notation. Basically, you already discovered it. When you're multiplying, a fast way is to add the numbers. When you're dividing, add the exponents. When you're dividing, you subtract the exponents. Okay? A student found the product of 3 times 10 to the third power and 8 times 10 to the fourth power to be 2.4 times 10 to the seventh power. What was the error? And the correct answer. Ooh, I'm going to use my calculator. So it's 3 times 10 to the third power. Let me show you. So right here, oops, you are watching me. Sorry. I didn't know that you were watching me. So I'm going to put it right here. And then I'm going to go, okay, so it was 3. I'm going to use the calculator. 3 times 10 to the third power. And then it's going to say times 8 times 10 to the seventh power. So what do I get? I get 2.4 times 10 to the 11th power. So it's not 7. What was the error? So the student, how did they get 7? Divided instead of multiplied is off by a power of 10 or rounded incorrectly. Well, the 2.4 is correct, so maybe just the power is off. The correct product is 2.4, but times 10 to the 7th power. Or, I see the correct 8. What do they do? Or, so a student found the product 3 times 10 to the third power and to be, what is the error? What he did is he added the exponents, the powers, and then multiplied 3 times 4, but then he just wrote it as 2.4. If you add the exponents, then he should have put 24. Or, the correct product is, never mind. I know. Hold on. So that should have been 2.4 times 10 to the 11th power. Let me put the 11th power. So it's going to be 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then if he would have done 7, then he needed how many? 4, 1, 7, 8, 9, another 0. So that would have been 2,000, 24,000. I'm going to check if I did it right. Let me see. Check the calculations to your answer to the multiplier, the product 7 as a power. Because my correct answer is 24. Let me see, 24, 7, 8, 9, 10, 11. He didn't divide, he multiplied. It's off by a power of 10. Let me see if okay, 2.4 times 10 to the power of 11. That's what I got. Did I put it in right? 3.3 times 10 to the 8 times. I put 10 to the fourth. Over here, 10 to the 7. I should have put 10 to the fourth. Okay. Yes, so it's 24. So it's off by a power of, so it should have been, let me see, 1, 2, 3, 4, 5, 6, 7, 8. Huh, it should have been 8. So that should have been 24. Uh-huh. And then this one, sorry, this is 8. Okay. So sorry that I was wrong. Let me see. Check. Got it. Thank you. And you guys, one of the reasons why I don't erase my mistakes and I don't record again is so that you know that I also make mistakes and it's okay. That's when my brain is growing and and that's it. Thank you so much. Bye bye.